Hello everyone, I am Golden Ashwini. I am here to present interfacing ADC and DAC with 8051. So, digital to analog converter and analog to digital converter are widely used in control operations and instrumentation in industries. Okay, as their name suggests, the DAC is to convert a digital input to its analog form. Then converting any analog input signal to its digital form is the job of any ADC. Okay, so in this we are going to discuss the DAC or ADC can be interfaced with 8051. Okay, so 8051 microcontroller, because of their widely available and the usage, we will take the 808 DAC and the 809 ADC in our examples for DAC as well as ADC. So audio interfacing is another area where the DAC are widely used. Okay, so then the next we are going to see how DAC works. Okay, for several standard methods to convert any digital signal to its analog form, we are generally using R2-2R ladder network methods is most widely used. That was shown in the figure. Okay, and then each bit of digital input is passed through a set of resistor network to its weight. The resistors used must be accurate values. In general, 2R is replaced by the value of 1M and accordingly R is calculated. Then the conversion time of this type of DAC is very less, generally a few nanoseconds. In general, not carbon but metal film type of are used for R2-2R ladder for the desired accuracy. Okay, next one is how an ADC works. Okay, several methods exist for analog to digital conversion, like ramp method, successive approximation method, then dual slope method and flash conversion method. Okay, the basic techniques used in ramp method is explained through this diagram. Okay, so in this case the input analog signal is compared with the output of the internal DAC, and whenever the output matches the end of conversation, the signal is generated and data becomes available at the output port. Okay, so to generate input for a DAC, a register, that means counter, is used, which keeps on sending digital values generated by continuous increments starting from 0. Okay, so generally a start conversion signal is necessary to initiate the whole process, and read signal is necessary to read the data. Such a procedure must depend on sequential logic demanding a clock signal, okay, which is generally supplied from external source. The whole procedure in this ramp method takes some finite amount of time and not an instantaneous one like a DAC. However, a flash converter type ADC is capable of converting the analog inputs to its digital form almost instantly, which uses the different techniques. The sample and hold. This schematic diagram shown in the figure. In most of the cases, the conversion from analog to digital takes a finite amount of time, and the input analog signal must remain stable during the conversion time. If a signal is of lower frequency, then it does not create any noticeable problem. However, for a higher frequency signal, it is essential to maintain the stability of the signal during this conversion. Okay, generally this is achieved by incorporating a sample and hold. This unit at input, okay, which during its hold state maintain the stability of the input signal through the external capacitor interfaced with it. Okay, that schematic diagram is shown in the figure, which accepts a digital input as a sample and hold signal. Hold is active low. Okay, input and output waveforms for different state, and this sample and hold signals are shown in the figure. Note that as long as the hold input is valid, that means low, the amplitude of the input signal does not change against time in spite of the changes in the input signal. Okay, however, during this sample state, that means high, the output waveform follows the trail of the input waveform. Okay, the sample and hold until is unable to hold the input voltage for a long time. The captured value of the voltage decreases slowly. However, most ADCs are fast enough to convert the analog voltage sampled within a reasonable time duration, so that the distortion may be neglected for the practical purpose. The next one is interfacing DAC. Okay, so to interface digital to analog converter with 8051, it is preferable to use any port to provide the digital data input to the DAC. As an example, the pin diagram shown the 0808 DAC is shown in the figure. As we observe 8 digital input signals. Okay, the DAC needs some reference voltage input also. So data input lines are designated as A1 through A8. Okay, A1 as MSB and A8 as LSB. Therefore, at the time of interfacing with port 1 of 8051, then port 1P 1.0 is interfaced with A8 and so on. Of DAC compensation needs of 0.1 microfarad disc capacitor between these pins and its pin number 3. Then all the outputs, that means at the output stage, an operational amplifier is necessary to supply sufficient current. Yes, so the resistor used be a metal film resistor of accurate values. It may also be noted as bipolar power supply is necessary in this case. Okay, so then the digital to analog converter may be used to generate various types of waveforms such as sine wave, triangular wave, ramps and square waves. Okay, these examples routines based on the interfacing of the circuits. Okay, these are for interfacing DAC. Then interfacing ADC, that means analog to digital converter. So analog to digital converter may be accept single or multi-channel analog input, and the output may be collected either through interrupt or by polling, depending upon the interfacing. Okay, then the figure shows the interfacing ADC, and here we are using ADC 0809 from National Semiconductor. Accept 8 different analog inputs to its 8 input channel and converts to the corresponding digital value at a typical rate of 100 microseconds per channel. Three address input lines are provided to select any one of 8 input channels along with the ALE signal to last a channel number. Okay, start conversion command then may be applied through the start input. The EOC output remains low through output of the conversion time and goes high after the digital conversion is over and data being available at the output buffer. Generally, the EOC output is interfaced with some interrupt input of the microcontroller. This digital output D7 may be collected through the output enable OE signal, and the whole process may then be repeated for another input channel. Okay, so to convert a fixed channel continuously, the EOC signal may be itself be used as a start signal by a hardware connection. The conversion time is depend upon the external clock source necessary at the clock input of the device. Okay, so the bandwidth is from 10 kHz to 1.28 MHz with a typical value of 640 kHz. This clock may be generated either through a 555 or a similar timer or by 8051 itself. For a proper functioning, reference voltage inputs are also necessary for the device. Okay, these are for interfacing ADC. Okay, thank you. Thanks for listening.